Hello everybody and welcome to math class. Go ahead and take your seats and get comfortable, put the snacks away, make sure you have your math notebook or some scratch paper or whiteboard and something to write on whatever it is you have to write on. So today we're answering this question. What the heck is a mixed number? We've been doing a lot of work around fractions that have a value of greater than 0, but less than 1. But what happens when we go greater than 1 and into the realm where we've got a whole number but also a fraction at the same time? What does that look like? What do we do? Here's our I cans down here. I can define the term mixed number, and I can add and subtract mixed numbers with like denominators. All right, let's get into it, everybody. Again, the chat is there for you to ask questions. There is a slight lag, so go ahead and ask them early so we can see them in time. Just as a reminder, over this shoulder, here's our numerator in a fraction. We're talking about how many pieces we've got, and then the denominator is the size that each whole number is broken down into. We had our number line from yesterday, or from earlier in the week, I'd say. I think it was Monday. We had our number line from Monday. So here's the distance between 0 and 1. We've got 0 over here, all the way up to 1. Everything in between are the fractions that we've been working with. And here's our fractions bar, more accurately drawn out to reflect that each piece is actually an equal number. This case, 1, 2, 3, 4, 5, 6 equal pieces, so we're dealing with sixths. And then each spot on our number line showing where 1/6, 2/6, 3/6, and so on is. And on our number line, we can clearly see, thinking about if 0, for instance, is like the starting point of a race, right? How far down that line are we going to go until we get to certain fractions? The further you have to travel, the greater the value of that fraction is. So 3/4 is greater than 1/2, for instance. But what about when we go past 1 and into the realm of the unknown here? This is where our mixed numbers come in. So a mixed number we're going to define as, and I'm going to write it right below here because we can still see it, a mixed number is a representation of a whole number and a fraction. A representation of a whole number and a fraction. So just like if we were to take the number 25, for instance, right? That's 2 10s and then 5 1s. A mixed number works the same way. It's some group of whole number and then a fractional piece on the end of it. So really it's kind of an extension of our place value work, where we're really just thinking about, moving from, in our numbers and place value, moving from right to left, we're getting larger, right? When we get into decimals, it really is going to stick to that 10 times larger every time you move over a thing. Fractions don't have to function by that base 10 system. We can have smaller groups there. But essentially what we need to know is a mixed number is a whole number plus a fraction, okay? If we go back to our clear whiteboard here, we can see that a little bit. So if we have like a number like 2.5, right? And again, in terms of spacing, our whole number is bigger and our fraction, our little numerator, denominator, a little smaller there. Our 2.5, if we wanted to draw it out, we use our fractions bar, but we don't have to break it up into anything because we're just using this as a 1, right? This is the same thing as our little ones cheese cubes, if we think back to our manipulatives days, okay? So we have 2, and we're going to have a half. So we're going to break one of these up into 2 pieces. And then we're going to shade in 2. Here's 1. Here's 2. And here's our half. Okay? If we wanted to do it like in the pie or the pizza way, same thing, right? 2 wholes, 2 ones, and 1 half extra. Okay, so really a mixed number is nothing we haven't worked on before. We've worked with whole numbers before. We've worked with fractions before. Now we're just working with both of them at the same time. Because we can add whole numbers, and because we can add fractions if they have like denominators, then we can add mixed numbers if our fractions have like denominators. So if we had something like, let's use this as an example. We can say 1 3/4 plus, well, we could even do 1 3/4. Okay. One of our properties of addition that's going to be really, really useful, it's our commutative property. Okay. That means that's the addends change, but the sum stays the same, right? This is our, 3 plus 4 equals 7 is the same thing as 4 plus 3 equals 7. Okay, because with addition, it doesn't matter what order our addends are in, it still equals out to the same sum. This is also true with fractions. If we think about a mixed number as a whole number plus a fraction, we could say that this 1 3/4 plus 1 3/4 is the same as 1 plus 3/4 plus 1 plus 3/4. And we can move any of these around to make them more useful to us. Okay? We could add 1 plus 1. Let's kind of take this bit and move it over here. 1 plus 1. And then we can add our 3/4 together. So 1 plus 1, obviously it's 11. Just kidding. 2. Okay? And then 3/4 plus 3/4. And let's draw that out with our fractions bars, because that could be easier to see. So we make our fourths. We're going to color in 3 of each, because it's 3/4 plus 3/4. And then how many fourths do we have? 1, 2, 3, 4, 5, 6 fourths. Okay? So here's our short answer. 2 6/4 is an acceptable answer. Okay? However, let's look at these 2 fractions bars here and think about, can we make a whole number with these 6/4? Yes, we can. If we take one of these fourths, move it up here, now we've got another 1 that we can add to this 2. So 2 plus 1 equals 3. And then we have 2/4 left, or for you smart cookies that can simplify this fraction, because 2 and 4 both go into 2, so we can divide by 2 halves. All right, this is the same as 3 1/2. All right, so when we're adding mixed numbers, okay, when we're adding mixed numbers, really important to think about here, when we're adding, we can use that commutative property to add our fractions, and then add our whole numbers, and then at the end, put them together. Let's try one more. Let's do 7 and 5/6 plus 3 and 2/6. Yes, that's not simplified, but we're using like denominators here. Okay, so let's think about first our fractions. 5/6 plus 2/6, right? Denominator stays the same. 5 plus 2 is 7/6. And then let's add our whole numbers. 7 plus 3 is 10. Could you leave it as 10 and 7/6? Sure, for now. However, see if you can go further. Because we have 7/6, and let's draw that out in a fractions bar, right? So here's our sixths, and we've got, if we have 7 of them, 1, 2, 3, 4, 5, 6. We need another fractions bar because we've made a whole number. And here's our 7th/6. Okay, so let's add this whole number to our whole number because we just made 1. So we've got more than 6/6. Okay, so 10 plus 1 is 11. And then here's our 6ths left over. So we can say 1/6 for a final and simplified answer of 1/6. Okay, 10 and 7/6. Mathematically that works, but it can be a little bit simpler. These are equivalent. Okay, 11 and 1/6 is just more simplified. It doesn't have what we call an improper fraction here. We're going to talk about improper fractions in depth tomorrow. What does this look like for subtraction? Let's think about subtraction of mixed numbers. This is where things can get a little bit tricky, but if we remember, okay, we've subtracted a lot when it comes to whole numbers, and fractions aren't any different than whole numbers. Okay, they just don't fit neatly into one box. All right, so if we have something like 1 and 1/5, okay, minus 2/5. Let's try that. I picked that one because we're going to have to decompose for it. So if I have 1/5, I can't take 2/5 away from that, right? I don't have 2 pieces to subtract. But I do have this 1. And if I break this 1 up into fifths, now I've got some more fifths to deal with. So the whole 1, I've got it. I already got it. 1 and 1/5, right? There's our 1 and 1/5. So let's decompose this 1 into some fifths. And now we have 1, 2, 3, 4, 5, 6 fifths. Now I can subtract 2/5, can't I? 1, 2. And I'm left with 1, 2, 3, 4 fifths. Okay? The key with subtraction of fractions, just like if we have subtracting whole numbers, we have something like 23 minus 4, right? We can't do 3 minus 4, so we've got to decompose one of our 10s and then add the 10 ones here to make 13 minus 4 is 9, 10 minus 0 is 10, right? We can decompose a whole number into our old friend, the fractional equivalent of 1. Okay? So if it's 1 and 1/5, I can take that 1 and I can turn it into 5 fifths without changing the value. Make sense? Okay. Let's try one more. Let's try a little bit of a trickier one here. Let's try something like this. 3 1/3 minus 1 2/3. Okay, so there's two ways you can go about this here. Okay, you can subtract your whole numbers and then subtract your fractions and kind of see where we're at, or you can kind of treat them like two separate things. So, you know, imagining if these were 10s and 1s, right? If we kind of could set it up vertically, couldn't we? And you can see here, I can't subtract 1/3 or 2/3 from 1/3. I need to make some more thirds. So I'm going to take my 3, I'm going to decompose it. Do I need to use all 3? No, I just need to use how many? I just need to use 1. So I'm going to, 3 minus 1 is 2. And then I want to think about how many thirds are in one whole. 3 thirds. So I want to add this to my 1/3 to make 4 thirds. Now I can subtract. 4 minus 2 is 2/3. 2 minus 1 is 1, to make 1 2/3. Look at that. 1 2/3 times 2 is 3 1/3. The other way you could think about it is if you wanted to do it like this. 3 minus 1 is 2. So now you're left with 2 1/3 minus 2/3. So subtracting the whole numbers first. It's a little bit, it can be more helpful for some mathematicians. It can be less helpful because it's different than our normal standard algorithm for subtraction. Okay, so for some of you, this might be confusing as all heck, in which case, don't worry about it. If this makes sense, use it, okay? Then we end up with 2 1/3 minus 2/3, and now we're kind of back at the same thing, right? Take one of our wholes and add it to the fraction, and we end up 4 thirds minus 2/3, or 1 4/3 minus 2/3 equals 1 2/3. Okay. If we're going to do this visually, because I do want to draw it out visually just for this one problem. So let's go back to our original. 3 1/3 minus 1 2/3. I'm going to rewrite it so we can see it visually here. Because I know for some of you it really, really helps to see those fraction bars. So 3 1/3 there's our 3 1/3 minus 1 2/3. Okay, so we're going to subtract the 1 straight away. Just, oops, go back to the black here. Get rid of one of those. Subtract it. Now we need to subtract our 2/3. But we can't do that yet. So we've got to take one of our whole numbers, break it into thirds. So then we can subtract 1/3, 2/3. And then, what are we left with? We're left with 1, and we're left with 2/3. Make sense? All right. Thank you, everybody. Let's go to the digital whiteboard for a few more practice problems. Okay, there we go, our first one, 3/7 plus 5/7. Okay, again, we could do this straight away, or we could do this straight away and end up with 8/7. Just like we would with our regular fractions. Let me get the green pen here. Denominator stays the same. Numerator is added. Okay? But let's think about this in terms of our fractions bars and think, can we make a whole one? So here's our 3/7. Here's our 5/7. Okay, 1, 2, 3, 1, 2, 3, 4, 5. All right, so if we have 3/5 plus, or 3/7, excuse me, plus 5/7, I'm looking here and I see, ooh, I see 2 open spots. So let's take our 2 of our 7ths, and we're going to move them over to our whole number. So now we've got 1 whole, and how many 7ths left over? 1/7. So it's 8/7, or 1 and 1/7. Okay. Let's try a couple more here. Let's try subtraction one. 1 3/8 minus 7/8. Okay, so this one again might be helpful to draw out. So we're going to draw our 1, and then we're going to draw our 3/8. So here's our 1 all the way colored in, and then 8ths. 1, 2, 3. Now we're going to subtract 7/8. 1, 2, 3. Uh-oh. We're out of 8ths. What do we do? Yeah, we're going to have to convert and decompose this 1 into 8/8. Right? So then we can subtract the rest of our 7/8. We've already subtracted 3. So 4, 5, 6, 7. And let's see how many 8ths we have left. We have 1, 2, 3, 4/8. 4/8. And for you smart cookies out there, can you simplify this fraction? What number will be an equivalent, or what fraction is an equivalent of 4/8? And if you look here, here's kind of your clue, right? We've got 4/8 on this side, and then 4/8 on this side. Kind of sounds like 2 equal pieces to me, doesn't it? And we have 1 of those pieces, or 1/2, right? And you get there by dividing by 4/4. 4 divided by 4 is 1. 8 divided by 4 is 2. Nice. Let's do one more before we get out of here. Should we do addition or subtraction? Let's take a look. Well, these are pretty quick. We'll do them both. So again, 2 4/5 plus 5 3/5. Okay? 2 plus 5 is 7. 4/5 plus 3/5 is, keep your denominator the same, and it's 7/5. Oh, take a look at that. Our numerator is larger than our denominator, which means we have a whole 1 that we want to, or some sort of whole number that we can convert. Let's draw it out. 1, 2, 3, 4, 5. Six, 7. So let's add that whole to our 7. 7 plus 1 is 8. Just like we would, carry over a group of 10 ones into one 10, right? And then what's our fraction left over? We have 2/5 left over. So we end up with 8 and 2/5. Okay? 7 and 7/5, mathematically accurate, but 8 and 2/5 is just a little neater. Okay? Last one, 8 minus 3/10. What? This doesn't have a mixed number in it at all. It's a whole number minus a fraction. What the heck do we do? You do the same thing that you would do if you needed to decompose to subtract a fraction by a fraction. So we have 1, 2, 3, 4, 5, 6, 7, 8 minus 3/10. So we know we have to take one of these whole numbers and decompose it into tenths. How many tenths in one whole? Numerator and denominator match. Yeah, 10 tenths. It'll be tough to draw this small. Got it mostly? All right, so we know we're going to have 1, 2, 3, 4, 5, 6, 7 left over. So we'll have 7 and something, right? So what's 10 tenths minus 3/10? Same as 10 minus 3. Keep your denominator the same. 10 minus 3 is 7. And you end up with 7 and 7/10. All right. Really the key here is knowing that if you need to make more fractions from your mixed number, you can decompose one of your whole numbers into a fractional equivalent of 1. So if you need some eighths, you can subtract 1 from your whole number, make 8/8. If you need some twelfths, you can subtract 1 from your whole number, make 12/12. And then use that to subtract while keeping the denominator the same the whole time, okay? On the exit ticket, some of the challenge questions have unlike denominators. I want to see how you can handle it. Can you make those fractions into like denominators and then add or subtract them? It's a next level of trickiness that we're going to get to as a whole class, but I want to see who can give it a shot already. No penalty for wrong answers on the bonus question, so give them a try. All right, math group A, you are going to be in the Zoom room shortly as soon as I get this video uploaded and published to YouTube. Everybody else, work on the exit ticket, drop into the Zoom room if you want help or some extra practice, and good luck. We will see you back here at 1:15 for science. Y'all also have a PE class to go to at 12:30. All right, good luck. Thanks for tuning in. Cheers.